Okay, so section 4.4 is on area of a triangle. And we're going to use this diagram, okay, in a little bit. Again, I'll draw that in after. Okay, so from geometry, we've done area of triangles before. Okay, and generally the formula you use is area equals 1/2 BH. Anyone remember what does B stand for? Base, and then H, height. Okay, so that formula assumes that you know those two things. Okay, you know the base and you know the height.
Can you scroll up a little bit?
Yep. Okay, if you don't know, let's say you don't know the height. Okay, you're going to have to use a different formula. Okay, so if you didn't have the height, let's look at the triangle up above. Okay, let's say you knew B, that's the base. And they gave you some other information. Okay, in this case, they're going to give us how long another one of the sides is, and they're going to give us an angle. If they give us those three pieces of information, that's enough to find the area of that triangle. Not using the formula that we're used to, but using a formula that's kind of based off of it. Right? So what I want to do is draw in the height. And you could do this with any kind of triangle. You could draw in a dotted line and put the height in there. Now, if we knew that, then all we'd have to do is 1/2 base times height. I want to calculate what the height would be here. Right? And I'm going to use three pieces of information to do it. I'm going to use that angle. That's what I want to calculate. And they're going to give me that. So first thing I have to do is figure out what the name of sides A and H are relative to their position of gamma. Okay, so what's H? That's opposite. Okay, H is opposite. What about A? A, yes, that's a hypotenuse because that's a 90-degree angle. They're going to give you A, and they're going to give you gamma. So we could definitely figure H out. Which trig function would you use that has opposite and hypotenuse in it? Sine. Very good. Okay, so using that diagram, we could say sine of gamma equals opposite over hypotenuse. So that's H over A. And how would we get H by itself? Yeah, times each side by A. That's gone, and that's gone. So now we have a formula to calculate the height. It's this length of side A times the sine of gamma. Right? Just using right triangle trig. Well, so now that's the height. Okay, the height is A times the sine of gamma. And what we're going to do is, in our formula, instead of having the height directly, we're going to use this formula. So we're still going to have 1/2 the base. We're just going to find the height a little differently. Okay, to find the height, we're going to do A times the sine of gamma.
So we're always going to use that?
Yeah, for these problems, yeah. This is one way to find the area of a triangle. Okay, so take just what I said, take 1/2 base times height and change height. Change it to what we just found the formula was. So now it becomes 1/2 base times the height, which is A sine gamma. And what they normally do when they write that is they just put it in alphabetical order. 1/2 AB sine gamma. Whether you do B times A or A times B, that doesn't matter. Switching the order, you multiply two things in, you get the same answer. Right? And there's three versions of that formula depending on which angle you know. But they all look very similar. There's 1/2 AB sine gamma, 1/2 BC sine alpha, and 1/2, what do you think the last two letters are? A what?
C.
Yep, AC sine of what?
Theta.
Theta. sine of
Can you
beta.
do something like similar to that?
Yeah, we can. When we did the law of cosines, I think I made a similar comparison. It was like a squared, b squared, c squared. They all equal. They all started with one of those. Yeah. And what I try to do, rather than remember all three of these formulas separate, is just remember the idea behind them. And then you can figure out any triangle problem where you know two sides and an angle. So in general, to find the area, it's 1/2 times 2 of the sides, any two you want, so 1/2 times 2 of the sides, times the sine of the angle between those sides. So 1/2 times 2 of the sides, times the sine of the angle that's between the two sides you picked. Let's say we had a triangle like this. That's our standard triangle, the way we always label it. A, B, and C. A across from alpha, B across from beta, and C across from gamma. So if I took A and B, the angle that I'd use is gamma. So it would be 1/2 AB sine gamma. If I took B and C, it would be 1/2 BC sine alpha. And if I took A and C, it would be half of A times C times the sine of beta. So just try to remember that idea. 1/2 2 of the sides times the sine of the angle between. Okay. Any question on the formula? So that's a different formula to find the area of a triangle. So we'll try a couple examples.
The area of what?
Area of a triangle. These formulas will work on any type of triangle.
Anything?
Yep. Could be like isosceles, equilateral, scaling, any type.
That's the insurance.
Okay. So here's an example. It says find the area. A is 8, B is 6,
Thank you.
gamma is 30. Right, let's just start out by writing down what the expression would be to find the area. Okay, so the area is going to equal what always comes right after area. Yeah, it always is a half. Doesn't matter what version of the formula you're using. So 1/2. And then what's going to come after the 1/2 here?
A.
Which is,
B.
yep, 8 times 6 times one more thing. Sine 30. Good. Okay, so let's do that up. 1/2 of 8 gives me 4. 4 times 6 is 24 times the sine of 30. Okay. Now we need to figure out the sine of 30. Are we in degrees or radians? Degrees. And if you type in sine of 30 on your calculator, you'll get a nice answer. Anybody see what you get? 0.5, yep, or 1/2. So that one comes out nice. And my final answer is 24 times 1/2, which gives me 12. Okay, now what did we just find? We found a what?
Wait, why is that 1/2?
The 12 is or it's an area. So what should we have for a label on that? Some units squared. Yeah. If they had labeled the 8 and the 6 as inches, I would have written 12 inches squared. If they put feet, I would have put 12 square feet. If they don't put a unit, just put 12 units squared. We don't know what the unit is. Okay, any question? Somebody have a question on how we got 1/2 for sine 30? No? That's just,
Jamie answered it for me.
yeah, you just plug it in, that's what it comes out to. The only reason I know that is because it's a special angle. If it was like sine of 32, I'd have to do it out. I wouldn't know what that is.
So you save the half till the end after you do the...
Yeah, yep. So I did my multiplication. then I did the trig function, and then I had one more product to do out.
Okay.
Yep. Okay. Any question on that? All right, let's try, let's see. Okay, let's try this one. Let's see, I did it like that. I don't have anything labeled. How would you set up your formula for the area now? Because nothing's labeled, so you can't really figure out which version of the formula you're going to use. Okay, so again, we don't know which version we're going to use, but it doesn't matter. Just try to remember the general idea. So what always comes after the equals? 1/2 times what?
4.
Times 4 times 3 times, right. It doesn't matter if the sides are A, B, or C. Just take 1/2 times 2 of the sides times the sine of the angle between them. Now, if you knew an angle that wasn't between those two sides, then that could be a little bit of a problem. Okay, but in this section, they're not going to do that. Okay, so 1/2 of 4 is 2. 2 times 3 is 6 times the sine of 30. Okay, we just did out sine of 30 a minute ago. What do you get when you do that? Comes out 1/2. 6 times 1/2 gives me 3. Yes, 3 units squared. That's the area. Okay, any question on that? Let's try one more. Find the area. This time the angle is 20. Okay, that's not a special right triangle angle, so we're not going to get a nice answer. If you don't get an answer that comes out to an integer or whole number, round it off. 2 decimal places is good. Okay, Josh, can you give me my formula that I'm going to use to find the area?
Times sine 20.
Okay, everyone agree with that? 2 times 5 times sine 20?
Half.
Yep. Okay. I'm going to put the 1/2 in there. Okay, what's 1/2 of 2 times 5? So 1/2 of 2 times 5 is 5, okay. Times the sine of 20. Again, make sure you're in degrees. And see what we got. Since there's nothing coming after the 20, if I don't close the parenthesis, that's okay. So we get 1.71 square units. Okay. Any question on that? All right, let's see. We gave you a problem like, let's call this one 3A and 3B. Let's say the area of a triangle is, let's say, 12 square units. Okay. The sides, let's see, 2 of the sides are 8 and 3. Find the angle between those 2 sides. Okay, how would you do that? Yeah, just fill in everything you know into our formula. Okay, so what's one thing we know? Okay, we got the area, so that goes by itself. Okay, what goes on the other side?
Sides are half.
1/2, yep,
Times 8 times 3.
times 8 times 3, good.
And minus the angle.
Yeah, times the sine of the angle. This time we don't know what the angle is. You can call it alpha or beta or x. You can call it whatever you want. Okay, sine of the angle. All right, so we get 12 equals, what's half of 8 times 3? 12. So we get 12 equals 12 times sine alpha. Okay, what would be my next step? Yep, divide each side by what? 12?
Why is it 12? I mean, why is it alpha?
You could pick any variable for the angle.
Okay.
Could be anything. 12 divided by 12 cancels, and what do you got? 1. So 1 equals sine alpha, but we don't want sine alpha, we want alpha. So take the inverse sine on each side. Take the inverse sine of 1. Okay, what happens when you take the inverse sine of the sine? They cancel out. Okay, now we have our angle by itself. So alpha equals inverse sine of 1. And we get a 90. So the angle was 90 degrees. Now if I asked you to classify that triangle, what kind of triangle is that? It's a right triangle. Yep. If you got an angle bigger than 90, what kind of triangle does that make it?
Obtuse.
It's automatically obtuse. If you got an angle smaller than 90, well, the angle is definitely acute, but we might not have enough information to classify it. Let's say I said to you, one angle in a triangle is 10. Well, maybe you have another angle that's 100, and then another angle that's 70. So in that case, it would still be obtuse. So if you get an angle smaller than 90, you might not know. Okay? Or if you got an angle that's 10, could you have an acute? Is it possible to have an acute triangle with an angle of 10?
Yes.
What if you had 85, 85, and 10? 85 and 85 is 170, and 10 is 180. Are they all less than 90?
Yes.
So yeah, it would be acute. So if the angle comes out less than 90, it's hard to tell. If it comes out more than 90, you certainly know it's obtuse. Exactly 90, it's right. Any question on that? Okay. So our second type of formula is for finding area of a triangle again. This time it's if you know all the sides. Okay, you're not going to know any of the angles. And this one's called Heron's formula. This one we are not going to go through the proof for. The proof, it's kind of complicated. It involves what's called a half angle formula identity, which we haven't done. Then it uses one version of the law of cosines and a lot of algebra. All right, simplifying common denominators. So the proof is quite lengthy. And you have to be very clever. I looked at the proof the way they do it in the book, and there's a lot of things you'd have to think of that you normally wouldn't think to do that. So we'll just look at what the final result is. So the final result is the area of a triangle is the square root of s times s minus a times s minus b times s minus c. Is there anything in that formula that we might not be sure what that represents? Yeah, we haven't used s before. Okay, what about a, b, and c? Those are the sides. Okay, what do you call the distance around the edge of a shape? That's the perimeter. Well, S stands for semi-perimeter. What do you think that is?
Not perimeter.
Semi-perimeter.
Half the, oh, perimeter?
Yeah, half of the perimeter.
I said perimeter.
Okay. Kind of like if you drew a semi-circle, half of a circle. Right? So to find the semi-perimeter, all you have to do is add up all your sides and then do what with it? Divide it in half. Take half of it. Okay, so to find the semi-perimeter, just add up all your sides and take half of it. So it's a pretty nice formula. And I think really the only way you appreciate it is to go through all that work of proving it, but it is very difficult to prove. But that's the end result. Because of the square root, most of the time you're going to get a decimal. You just round it to 2 places. Okay, but what's nice about this formula is you don't need any of the angles. All you need is the 3 sides. And they don't have to be bases or heights like they do in the basic formula. So this formula allows you to know any sides you want, not just a base and a height. Now, we haven't actually gone through it yet, but do you think it matters which side is A, which one's B, and which one is C?
No.
No, because in the formula, you've got to do S minus each one of them. So it doesn't matter really which one is A, B, or C. Okay, so in example 4, we've got A, B, and C. What's the first thing I should find before I can even really use the formula? Yeah, I got to find S. So add up your sides. And then take half of it. Or divide by 2. Same thing. So 4 plus 5 gives me 9, plus 7 is 16. Half of 16 gives me 8. So now I've got S, A, B, C. Okay, so fill them in and see what we get. So area equals square root, and what comes first? 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. And at first, when people saw a formula like this, how many things are you multiplying together? 4 things. When Heron came up with this formula, a lot of people didn't think that that could work at first, because they understood area as multiplying 2 things together. Whether it's a base and a height, or in a rectangle, we call it length times width. It was commonly understood you multiply 2 things together to get area. So why would you be multiplying 4? So for a while, this formula wasn't completely accepted because people didn't understand it. The tricky part in here is the square root. Okay, that's what makes it work out. Even though you're multiplying 4 things together, the square root fixes the units part.
For the 8,
All right. Yeah, 8. And then the 4 factors. Okay, let's do out as much as we can without our calculator. 8 minus 4 gives me 4. 8 minus 5? 3. And then 8 minus 7? 1. Okay, 8 times 4 times 3? How much is that? Yeah, 96. And in this section, we won't reduce the square root. We'll just plug it in and round it to a decimal. So it's about 9.80. And what should be my label on that number?
Unit squared.
Yep, unit squared. So again, at first this formula seemed kind of weird, but it does work. Okay, 9.8 square units. Okay, any question on that? All right, so let's say I gave you a problem on the test that said, I want you to find the area of the Bermuda Triangle. And the Bermuda Triangle is formed by 3 different points. I know Miami is one. I'll give you the other 2 on the test. And I told you the distance between all the cities. Okay. How would you find the area of the Bermuda Triangle if you knew the distance between all the cities making up the sides of the triangle? That would be Heron's formula. It'd be like you know the side lengths of each side of the triangle. Right, so I might give you something like that. Okay, you'll have to pick which formula you'd use. Okay, let's do this one. What's your semi-perimeter here?
8.5.
8.5, yeah. If you add everything up, 8 and 4 gives you 12. Plus 5 is 17. Then take half of 17. 8.5. Okay, now you don't know what side A, B, and C are, but we've already said that doesn't matter. A, B, and C, as long as you do 8, 5, and 4, doesn't matter the order you do it in. Okay, so try that one on your own. See if you can figure out the area of that triangle. Okay, so we've got our semi-perimeter. Okay, so what comes first? Square root of, yep, that's your semi-perimeter, times what comes next? Yep, 8.5 minus 8. 8.5 minus 5. Yep. And you just have to do all those out. 8.5 minus 4. As far as multiplying the decimals, we'll use our calculator for that, but let's do the subtraction. What's 8.5 minus 8? So that's 0.5. 8.5 minus 5? 3.5. And the last one, 8.5 minus 4? 4.5. Let me show you how you type all that in. So I'm just going to type it in one step. So square root of 8.5 times 0.5 times 3.5.
Can you just plug it in over the left hand?
Yeah. Type it in. Just make sure you got it all typed in right. And you get about... Oh, that's what everyone got?
Yeah.
Okay, so about 8.18. Okay, yeah. Great, good. So the area is about 8.18 square units. Okay, any question on that one? All right. So next we're going to look at a special kind of triangle. Okay. Everything we've done so far could be applied to any triangle that you have. Okay, our next formula is going to be special to an equilateral. And what we're going to do is we're going to use Heron's formula to come up with a formula that's special just for equilateral triangles. First thing we have to do is label this diagram. What's an equilateral triangle? Okay, it does mean equal angles, and it also means, yep, all the sides are equal. Okay, I don't know what any of the sides are here, but I know they're all equal. So how could we represent, let's just say the bottom side for now. We don't know what it is, so we have to give it some way to represent it. B, yeah, or A or X, any variable. Okay? Let's just call it X, since we don't know what it is. What does that mean the other two sides would be? Yeah, they'd both be X. Because this is an equilateral triangle. So all the sides are the same. Now we're going to plug this into Heron's formula. All three sides are the same. So we're going to have a lot of repeat here, which is going to simplify quite a bit. Okay, let's start with our semi-perimeter. Add up the three sides and take half of it. What's x plus x plus x? 3x. And then take half of it. So 3 over 2. Okay, so 1.5x. Okay, now fill it into Heron's formula. So we have 3/2 x times, what's going to come next? Yep. So it's the semi-perimeter minus a side. What comes next?
Same thing.
Same thing again. Semi-perimeter minus another side. And then one more time. Semi-perimeter minus another side. So for now, just keep the 3/2 x in front. You can't really do much with it. But each one of those simplifies to the same thing. It's 3/2 x, take away 1x. What's 3/2? Or think of it as 1.5x, take away 1x. A half. Right? Pretend there's a 1 here. 1.5, take away 1, leaves you with 0.5 each time. Any question why 3/2 minus 1 is 0.5 or a half? Okay, so you get 1/2 x. How about in the second one? The third one, yeah, 1/2 x. And same thing again. What operation are we doing under that square root sign? It's all the same operation. It's all multiplication. It's 3/2 times x times a half times x times a half times x times a half times x.
Why is it 1/2?
Because 3/2 is 1.5, take away 1 is 0.5. So if we're going to multiply, does it matter what order I multiply all that in? No. So let's group all the numbers together. Let's group all the letters together. So we have 3/2 times a half times a half times a half. I just put all the fractions together. Times x times x times x times x. What would that be? X to the 4th power. Now we can simplify this entire fraction. The numerator is 3 times 1 times 1 times 1. What does that become? 3 over 2 times 2 times 2 times 2. 16. And the x to the 4th we still have. Now our last step to simplify that, you take the square root of each part of this separate. Take the square root of 3, square root of 16, and square root of x to the 4th. Okay, some of this will come out nice. Square root of 3 doesn't. What's the square root of 16? 4. And what's the square root of x to the 4th? What two things can you multiply together that give you x to the 4th? X squared, yeah. X squared times x squared is x to the 4th. And there's your formula to find the area of an equilateral triangle. All you need to do is take the length of the side, square it, multiply by the square root of 3, and divide by 4. And that's a shortcut to using Heron's formula. So it's x squared times square root of 3 over 4. And again, x is the length of a side.
What did you do over there? That jumbo.
Right here? So I took the square root of each thing that was under the root separate. That's how you simplify a square root.
Did you multiply them?
Oh, to get to the square root? Yep. I did 3 times 1 times 1 times 1.
Okay.
And then 2 times 2 times 2 times 2. And I did the x times x times x times x in the previous step, x to the 4th. Now, do you think this formula is more useful or less useful than the other two?
Less.
It is. It's less useful. How come?
It only works for equilateral.
It's only going to work for an equilateral triangle. But it's fast. Very quickly, if you told me, I have an equilateral triangle and the length of one of the sides is 7. So I just take 7 times the square root of 3, divide by 4. There's your area. Yep, you got to divide by 4 at the end. Okay, so it's a very fast formula to use. It's just not as handy because you can only use it for that.
It's the same formula, but
It's really just Heron's formula, but reduced. because you're going to get the same thing repeated 3 times. So if 2 people would have, let's say I gave you the side length was 7, and you both started finding the area at the same time, the person using this formula is going to get it done faster. Because the person using Heron's formula is going to have a repeat 3 times of the same calculation. It's going to take longer just to write it down. Okay, so I typed something wrong. Times, that's what your area would be. I'm not sure what the calculator did the first time or what I did, but. Hey, any question on that formula? Okay, so those are our formulas for area of a triangle. Okay, last thing I want to do is take a quick look at kind of what we're going to spend the rest of the week on. Okay, which is a little bit more abstract than the area of a triangle. Okay, so way back when we did unit circle trig, we had a formula. We said sine was equal to, and it was a certain letter. Cosine was equal to, and it was a different letter. And then tangent was equal to, and it was a fraction of 2 letters. Does anybody remember what sine was equal to? Which letter?
Y.
Yep, it was y. Cosine? It was x. And tangent? Y over x. Yeah, we divided it. Okay. So then we could say that tangent really equals something else. You can write it as y over x. But based on what we know y over x are, how could you write tangent? Tangent is sine divided by cosine. Okay, let's try that with a specific number. Let's pick an angle somewhere between 0 and 90. 45. Okay? So if we take the sine of 45, divided by the cosine of 45, and I get 1. Now let's just try taking the tangent of 45. What should I get? I should get 1, and I do. Comes out the same. Okay, let's try, that's a special angle. Let's try one that's not a multiple of 30 or 45.
26.
46?
26.
Oh, 26. Okay. So let's take the sine of 26 divided by the cosine of 26. Okay, you get that. Now take the tangent of 26. Same thing. So if you take the sine of an angle, any angle, divide by the cosine of it, you'll always get the tangent. All right. Let's take a look at something else. Let's look at tangent equals sine over cosine. How would I get rid of the cosine in the denominator? Times each side by what? Cosine. And times by cosine. So this is really the same identity, just rearranged a little bit. If you take the cosine times the tangent, you'll get the sine. Okay, let's try that with a different angle. Let's do 34. Okay. Take cosine of an angle times the tangent of the angle. You get 0.559. Now let's just do the sine of the angle. 0.559. So multiplying the cosine times the tangent gives you the sine. Any question on that? Okay, these are called trig identities. Let me show you one more pattern. Take the sine, square it. Take the cosine, square it, and then add them up. Let's see what happens. Okay, somebody pick any angle between 0 and 90. 27? Okay. Let's take the sine of 27, square it, take the cosine of 27. And I'm putting parentheses in so my calculator doesn't get messed up with order of operations. What do you think I'm going to get? Any guess? Let's see. 1. Let's try a different angle, see if we still get 1. Let's try, I'll pick something simple. Let's do 88. So let's do the sine of 88 squared plus the cosine of 88 squared. Still get 1. Right? And that's another trig identity. Okay? We're going to go through these a little bit more organized when I explain them, but I'm just trying to show you kind of the basics of what we're going to do. So if you take the sine of any angle and square it, the cosine of any angle and square it, you always get 1. Okay, so let me show you one last one, and then we'll stop.
It's always going to be cosine and sine?
Yeah, that one is cosine and sine. There's 2 other ones that are similar to this. Works with tangent and secant, but we'll talk about that more later. Say I gave you this. Sine squared plus cosine squared divided by tangent. Okay, so what they might ask you to do on a problem like this is to simplify it as much as you can. Well, based on what I showed you earlier, what's sine squared plus cosine squared? It's 1. So that entire numerator disappears and becomes a 1. You get 1 over tangent. But that's just flipping tangent. Does anyone remember which trig function do you get when you take tangent and flip it?
Cotangent.
You get cotangent. Very good. So this, all of that, is equal to just that. And that's the idea of simplifying a trig identity. They're going to give you a problem, and you take other identities that you know to help you simplify it and get down to something simpler. That's the basic idea. Okay, so that's what we're going to focus on Tuesday. We won't get to this sine squared and cosine squared stuff till Wednesday. We'll start out with some more basic ones than that. Okay. Any questions on that? Okay. All right, so the homework tonight, I'm just going to stick with the area of a triangle. We're not going to do any of the identities in tonight's homework. Okay, so the homework will be on page 280. 6 to 16 even, 20, 22, and 33. And a hint for number 33, when you read it, they want the area of this small region right here. Well, if you can find the area of a sector, that will help you. Okay, area of a sector, that's a formula we learned the first week. Arc length and area of a sector. Okay, so you'll need that.